This begins Chapter 3, Lesson 1. This is a unit on dealing with rational numbers. And today we're going to be focused on fractions and decimals. First thing we're going to do is go over this is Chapter 2.7, but I believe it's just over Chapter 2. Evaluate the expression, the absolute value of a, if a is equal to a negative 8. Is the answer A, negative 8, B, 1/8, C, 2, or D, 8? And your answer is D. Evaluate the expression b plus c if b is equal to 2 and c is equal to a negative 5. Is the answer A, negative 7, B, 3, C, 3, or D, 7? And your answer is? Evaluate the expression negative 3a if a is equal to a negative 8. Is the answer A, 24, B, 18, C, negative 11, or D, negative 24? And the answer is evaluate the expression c minus a if a is equal to a negative 8 and c is equal to a negative 5. Is the answer A, negative 13, B, negative 12, C, 3, and D, 13? And your answer is? Evaluate the expression a divided by b if a is equal to a negative 8 and b is equal to 2. Is the answer A, negative 8, B, negative 4, C, negative 1/4, or D, 4? And the answer is? So here's an example where we have a reflected image. So triangle ABC is shown on the coordinate plane. Find the coordinates of the vertices of the image of the triangle ABC reflected over the y-axis. Remember when we have those reflected over the y-axis, we multiply the x-coordinates by a negative 1. And remember, if you need to, you can pause the video too. And your answer is C. Alright, so we have used number lines to graph integers. We've done that. We did that a while ago. You've done that in previous lessons. So now what we're going to do is we're going to write fractions as terminating or repeating decimals. And then we're going to compare some fractions and decimals. So the first vocabulary word you have is a terminating decimal. It just means that when you are dividing out, you are going to get a remainder of 0, and division ends or terminates. That's what terminate means. It just means to end. And a repeating decimal is one of those decimals that repeats on forever. The pattern of the digit repeats without an end. Sometimes what they use is this bar notation. So instead of writing 0.33333333 after 1 3, since all that repeats are the 3's, they just put a line over the 3. And that's just what that bar notation means. It just means that the another example would be like 0.35, 35, 35, 35, 35. They just put a line over the 35 to show you those are the numbers that repeat. So now here what we're going to do is we're going to write a fraction as a terminating decimal. So we're going to write 1/16 as a decimal. If you go through and you divide it out using paper and pencil, you're going to place the 1 in your bar. You would put the decimal point and x and zeros, and then divide as you're dividing with whole numbers. And this is just going to show you how you end up with a terminating decimal. So the fact that the division ends when the remainder is 0, that's how we know it's a terminating decimal. Now you can also go through and just use a calculator, which I'm sure is what you all are going to do. I can't imagine any one of you sitting there and plugging it out. When you plug it in, doesn't matter which way you go, either way you still get the same answer. Now, go through, divide out 5/8. Which one is the correct decimal? Is it A, 58 hundredths, C, 625 thousandths, C, 725 thousandths, or D, 5 8/10? And the answer is Alright, so now we're going to write 6/11 as a decimal, and we're going to use that bar notation to show what part of our answer repeats. So if you notice when you go through and use the calculator, it'll go 0.54 and the 5 4s will keep repeating. So we're going to use a little bit of mathematical shorthand, because who wants to keep writing 5 4 all the time? So we put a line over the 5 and the 4. You're going to have to be very careful with that. Put a line over the 5 and the 4 because both the 5 and the 4 repeat. Alright, so now we're going to write a -4/33 as a decimal, and we're going to use a bar to show a repeating decimal. So here we go, we get the digits 1 and 2 repeat, so we're going to put a line over 1, 2, and notice it is a negative fraction, so we have to make sure we include that, not lose our negative sign along the way. So now we're going to write 9/22 as a repeating decimal. Which one shows the correct representation for 9/22 as a repeating decimal? Is it A, B, C, or D? And the answer is D. Notice the difference between A and D. In A, the bar notation goes over the 4, but when you divide it out, it does not go 409, 409, 409. It just goes 409, 09, 09, 09. So the bar notation is just over the 0 and the 9. When you write your answers, it's going to be really important that you pay attention to how far that bar goes, and it only goes over the the numbers that repeat. So write -2/3 as a decimal. Use bar notation to show a repeating decimal. Is it A, B, C, or D? And your answer is A. 2/3 is always going to be 6/10 repeating. So here are some very common fraction decimal equivalents. It is a good idea to have most, if not all of these, just in your head. It just makes your life so much easier if you can do some of these in your head. If you have it memorized, then you don't have to plug in a calculator, and it's good because you're not always going to have a calculator wherever you go. Alright, so Camille's soccer game won 32 out of 44 games to make it to the championship. To the nearest thousandths, find the team's rate of winning. So we're going to divide 32 by 44, and it says to the nearest thousandth. This is going to be another key point to remember, is reading the directions carefully and seeing at what point they want you to stop with your decimal. So if you remember, in the decimal point it goes tenths, hundredths, thousandths, so it's 3 points behind the decimal. And then they're going to have you round down since 2 is greater than 5. So their percentage is 727 thousandths, which is a pretty good percent rating. Alright, so the results of a poll showed that 16 out of 24 students in Ms. Brown's class would prefer going to the planetarium rather than the arboretum. To the nearest thousandth, what part of the class preferred going to the planetarium? So when you divide 16 by 24 and you round to the nearest thousandths, what place do you get? A, 7 thousandths, B, 667 thousandths, C, 700 thousandths, or D, 16 and 24 hundredths. And the answer is B. Now we're going to do some comparing with fractions and decimals. So you're going to replace the dot with the comparison symbols or the equal sign to show a true statement regarding 7/10 and 13/20. So you're going to want to convert that fraction. Well, you can do it two ways. You can convert your decimal into a fraction and compare two fractions, or you can convert your fraction into decimals. I would think it'd be easier to convert your fraction into decimals because you have your calculator that can do that for you. So convert them into decimals, and when you see that you have 7/10 and 65 hundredths, 7 is greater than 6. And you can show it on a number line, and the answer is that 7/10 is greater than 13/20. Alright, now you're going to try the same thing here. Use the compare symbols to change 11/15 and 13/25 to a true sentence. Now here you have, I would convert both of these fractions, because who wants to figure out the greatest common factor between 15 and 25? So go through and convert both of these into decimals, and you have 73 with a 3 remaining, and then a negative 52. They're both negatives, in fact, and so they show them on the number line there below. Because remember, with your negatives, the farther away they are from 0, the smaller they are. And so we can say that 11/15 is less than negative 13/15. I think it's supposed to be negative 13/25. They typed in that answer wrong. The comparison symbol's right, it's just the fraction they wrote was wrong. So now replace the dot with comparison symbols or equal to show the relationship between 3/8 and 4/10. Is it A, B, C, or D, none of the above? And your answer is A. Alright, so now, which of these 4 statements is true? Is it A, B, C, or D? Remember, you can pause the video and take time to figure out which one. And this is the benefit here of knowing some of your fractions, having your fraction decimal equivalents memorized. I already know in my head what 2/3 is, so I don't have to go through and solve that one, but I don't know 7/12 off the top of my head, so I only have to solve for one. And your answer is so now we're going to compare fractions using decimals. Jeremy got a score of 16 out of 20 on his first quiz and 20 out of 25 on his second quiz. Which grade was the higher score? So now we're going to write the fractions as decimals and then compare the decimals. So quiz 1, he got 80%, and quiz 2, he got also 80%, which means the scores were the same. So now, one recipe, this is for you to do, for cookies requires 5/8 of a cup of butter, and the second recipe requires 3/5 of a cup of butter. Which recipe uses less butter? A, the first recipe, B, the second recipe, C, they both use the same amount, or D, you cannot figure it out. It cannot be determined. Pause the video if you need to, and solve for 5/8 and 3/5. And your answer is... And that concludes your lesson.